Hello, everyone. Welcome to the 13th and last lecture of the information visualization course, which is entitled Hot Topics in InfoVis. So today is going to be a short one. We're going to be discussing, well, hot topics. And for the purposes of this lecture, I define hot topic as topics beyond the theory in previous lectures that are actively researched by the visualization community. So most of the topics that we have seen sees continuous research, but we haven't covered everything in this course. So I would like to introduce briefly some other things that are well hot in InfoVis right now. As the selection prism, I have used the IEEE VIS 2020 conference, so the last rendition of the top conference in the field. You can actually visit the virtual conference yourself at following the given link. I think, or it appeared to me that it's accessible without login now. So they have really promoted open access to all the articles, and I have managed to get all the content without logging in. Now I cannot rule out that I have used the computer that has been logged in forever and it just remembered the session, but I hope that you would be able to join if you're interested. And in this lecture, I mean, we're going to be introducing papers like normal, with the kind of optional reading references at the end. But you can also directly search by name, and the search engine for the conference should give you the paper directly. Before I start getting into the hot topics, I would like to discuss the cold topics in big quotation marks. So, are there actually any topics that are cold? So, from the theory that we have discussed before, that don't see continual research. So, actually, none of the topics that we discussed in this course are really 100% solved in the absolute sense. So there is active research from the fundamentals of the theory. There are many interesting psychological papers that kind of discuss cognition. So from the level of how our brain processes visual information to actual visualizations and advanced systems, everything is up for grabs when it comes to research. Of course, bearing in mind that the fundamentals of InfoVis are pretty much set. So we, for example, don't expect a new basic plot. So something that will join the family of like bar chart or line graph. There's going to be like a fourth, fifth technique that suddenly will be used everywhere. It would be very, very difficult to do. Also, there probably won't be new Gestalt laws and like basic stuff like this, but none of the topics are really cold. So everything is up for grabs. So really, we are going to be discussing what is extra to the theory we have discussed before. And also, please note that the introduced work here, it doesn't mean that the papers that we're going to discuss here are the most important papers of the conference, right? It's just those that we haven't discussed before, or topics that we haven't discussed before. So I will have to start with scientific visualization, or SciVis. I have briefly mentioned it in the first lecture as the third family of visualization techniques. To remind you, it delves into 3D visualizations or models of natural phenomena, or it can be nature, astronomy, medicine, physics, that stuff. So we see examples here. So this is a scientific visualization of a brain, and this is some typhoon or hurricane of a coast. I think this is Japan, I believe, but it's just a screenshot to illustrate to give you an idea what a SciVis is. Note that scientific visualization is the sister of InfoVis for many years now, decades even. So I would say it's hot in the sense of actively researched and needed, and not in the sense of new. So it's not an emerging topic. It's a very mature discipline, but indeed it sees a lot of attention and deserves a lot of attention in so many successful applications. I really like this one paper. So it actually won the best short paper award. So we discussed that scientific visualizations are 3D models, right? And to really render them, you need very powerful machines, and to really utilize scientific visualizations, there is some price barrier that you have to pay to be able to really work with the top of the line approaches. But there was this this paper called the Anatomical Edutainer by Schindler and his fellow authors, where you actually print the visualization designs on 2D color printers. So you just print it on a sheet of paper. You fold them according to the plan, and then basically you use colored glass, blue, red, and green, and you can inspect various layers of bodily organs or various like circulatory system, respiratory system, and so forth in 3D. I think this is a very cool idea. I mean, I'm evidently not alone in this thought. It won the best short paper of the conference, because it really destroys the price barrier. So like if you want to educate kids, want them to explore the human body, you can just do this for very cheap. You need a piece of colored glass or foil, and you need a piece of paper and a regular printer, so not even like a 3D printer, and you're cooking. So this is a very cool idea, and it deserved the positive attention it got, I would say. Again, so scientific visualization, as you might notice, is a very nice content for slides, because it's usually very beautiful pictures. Here we have an example from medicine, so called void space surfaces to convey depth in vessel visualization. So those are actually vessels that carry blood in our body. And another example from astrophysics is this interactive black hole visualization, where they have overcome the computational challenge to make it render very smoothly and observe or interact with the processes that happen in a black hole. So scientific visualization is a very cool discipline that would frankly deserve its own course, I mean, there's enough content for it to be its own course, so that's why we didn't really have the time to go into that in our course, which is a pity. And also the challenges are a bit different. They are more shifted towards the computational side of things. Because I mean, you're visualizing the phenomenon, right? So you're not creating abstract representations really. You're trying to directly visualize the phenomenon, and you need great computational power and very efficient algorithms to render things to make it happen. So the challenge is a bit elsewhere. Whereas in InfoVis, it's not really about computational challenges, unless we are at very large data sets, but we need to be careful about the representation of our data. So scientific visualization, definitely a big thing. Next, we have explainable AI. I think it has been very well motivated by Jack van Wijk in his guest lecture. So I refer to his motivation. I think that really hit the nail on the head. So we have seen that automated decisions by various systems are gaining traction in many domains, and it concerns various areas of our lives and an increasing number of areas in our lives. But we often don't know what the reasoning behind these decisions is. And there's a big problem in that as the AI becomes more capable, the model makes less intuitive sense. So like if we go a couple of decades back, then for example rule-based classifiers were very popular. If A equals X, then it's this class. Then we had decision trees, which are, I believe, also quite readable to people. You start at the top, and then you always hit a boundary or a decision point, then you branch accordingly to what the value of your data is, and then you arrive at a class. So that's also very intuitive, readable. And now we have deep nets, which are not intuitive at all. And the problem is that the models are not even intuitive to people that design them. So it's not that it's not intuitive to casual community or to lay community. But if you design deep net architectures, you of course have some intuition about what works and what doesn't, but you don't really know why, because deep nets have hundreds of millions of parameters, and sensible questions such as why does the net think this is a picture of a panda are impossible to answer. So you can train the net to classify pandas beautifully, but if you ask, okay, so why is this a panda? then the deep net will not answer you this question, and even the designer cannot really answer you that question. And given that the AI models are involved in our daily lives more and more, this might be a problem. So explainable AI to the rescue. It's a discipline that strives to turn those model black boxes, so those ununderstandable opaque models, into white boxes, so that we know why things work the way they do. Note that XAI is a very multidisciplinary thing. So it's not only InfoVis or visual analytics, but also the fields or communities of human-computer interaction, which is a bit of a different thing than InfoVis, machine learning, information retrieval, multimedia analysis, and computer vision communities, and possibly others, all chip in to make explainable AI a thing. And at IEEE Vis 20, there has been a massive number of XAI papers. So I will only select a couple that caught my attention. There were many, many more, and definitely not worse ones. All of them very nice. But this I think was one of the, like, by the numbers, it was the largest hot topic in InfoVis there was at Vis 2020, and the number of XAI papers each year is rising. So we have already seen this. So this is VATLD, Visual Analytics System to Assess, Understand, and Improve Traffic Light Detection. It has won Best Visual Analytics paper, so it's definitely a remarkable piece of work. Basically, what happens here, so why is this an XAI paper? We have a deep net that tries to classify or tries to recognize and locate traffic lights for autonomous driving. And sometimes it makes mistakes. So they have created this multi-view diagnostic system to highlight why certain things were classified the way they were, to gain additional insight into how the net has scored each image, localized the traffic lights, and to diagnose the mistakes. So the model here is representation learning plus semantic adversarial learning, visual summarization, and as we see, there's some nice multi-view design on top of the model, including multimedia data. Well, that's the domain, right? So those are the images. So here we see that they make use of something that is called adversarial examples. So those are examples designed specifically to confuse a net. So you would think that, okay, this is clearly a green traffic light, and the net will think that there is no light, or that the light is somewhere else. So those are these sets. We have discussed this during the lecture with Jack van Wijk as well, that you can have this adversarial example set to really test your net, whether it falls into the traps or not. And again, the problem is that the fact that your net has passed all the adversarial examples doesn't mean that your car that is going to have this model will not crash. So that's still a big open problem. But you can do this to kind of fine tune the net and plug in as many holes as you can, basically. So VATLD should allow you to do general diagnostics of your model, of this model, better than you would do with just trying out adversarial examples, retraining the net, and kind of shooting in the dark. So best VA paper for the last conference. The next thing, or next nice system, I think we have seen at Vis 20 was instance flow. Visualizing the evolution of classifier confusion on the instance level. Here what happens is that basically it allows detailed and customizable inspection of classifier confusion. So classifier confusion, for those of you that are not very familiar with machine learning, it's that if you have multiple classes, then that means that your data is being classified into different classes than they actually belong to. So here we have classes such as plane, auto, bird, cat, deer, dog, frog, and so forth. So if I have an instance of, say, a bird, and it will get classified as a ship, then the classifier has been confused. And basically visualizing, and we can easily do easily do like what is called a confusion matrix. So we have rows and columns are going to be classes, and we're going to count the number of misclassifications. So the rows are going to be the truth, so the true class. The columns are going to be classified as, and we're gonna record the count on in each of those items, like this has been classified as this. So of course we want everything on the diagonal. So plain classified as plain, auto classified as auto. But if we inspect the confusion matrix, we can easily see which classes are being the most confused by the classifier, which can help us with further diagnostics. And here, this system basically is on the instance level, so it's a highly customizable pipeline. It resembles some of those graph/text analytics approaches we have seen in lectures, I believe 8 and 9, and if you add instance level, then it will allow you to compare, to actually visually inspect the image. So if you just record a count in a confusion matrix, then it's kind of nice, but it's still nice to drill down to the data instance level to see where the confusion might be. So it will allow you to understand your model better. So here for the summary, I wrote that examples are always a good idea, but sometimes they will not help you. So you will see, yeah, but I still don't know why this is confused. But it still conveys this is a complicated problem message better than just a black box model. So even if you don't get your desired result or your desired understanding, then at least you can conclude that, yeah, this is a complicated problem, and you have it supported by examples at least. So that's the worst case scenario, but still better than just going in blind. Then we have DECE, Decision Explorer with counterfactual explanations for machine learning. I really like this one. So here we have a bit of a dashboard, which I'm going to go in a minute, not in the detail, but basically the main point here is that instead of just showing the problems, the DECE will try to fabricate what is called a counterfactual explanation. So if you get an undesired prediction or classification, so you have tried to classify something and you receive the wrong class label, it will generate the data instance with minimal changes that would receive the desired label. So their case actually is, I'm going to jump back. It was, I think, an insurance company or a bank, I believe, where you would apply for a loan. Right, and you have two classes: fail or admit. So actually, sorry, this visualization is for university admission. But it's the same principle. But I'm gonna sorry for the confusion. I'm gonna explain it, and then we're gonna jump back to the example. So you have a bank which will say, okay, approve loan, disapprove loan, or reject the loan proposal. And you will submit your financial information, and you get the result that your loan has not been approved. So what you would appreciate is something like, if you would have an income of 40K per year rather than 30K per year, your loan would have been approved. So then you kind of know what you need to fix or what the conditions are. You can make a decision to approach a different bank or resolve your situation in a different way. And it's a useful thing to have, right? So you get okay, I haven't classified you the way you wanted, or the data, it doesn't have to be personal, right? I haven't classified the data the way you wanted, but this is why this is what you would have to change to be classified correctly. And here here is the same example, but with university admissions. So you have so you have a fail, so you have failed the exams or the entry exams, and you have been admitted. So, and here you have various visualizations that help you uncover the statistic distribution of the multivariate data: GRE score, TEFL score, SOP, LOR. Those must be some various classification things or scores, appraisals, and DECE will allow to kind of generate, okay, you haven't been approved because your grade average is low or something like that. So I really like this approach. I think it's worthy of further attention and research. And so those have been just a couple of examples. There's much more. And if you are a person interested in XAI and would like to see all the XAI papers, there are actually entire paper sessions that are relevant to XAI. So if you would go to the conference link, the session Sense and Explainabilities, all of it is pretty much XAI, making sense of text, visualizing machine learning, and there might be more. So there's a lot of content in XAI for the last IEEE Vis. And if you're interested in a good overview of previous work on XAI, you can read this paper by Homan, which is included as an optional reference at the end of the lecture. So going further, there's also what is called the immersive visualization and analytics. This acronym, by the way, is something that I have created so that I can use it on titles of further slides. So I'm not sure that, so this might not be the official acronym, but the discipline is definitely called immersive visualization and analytics. And what it is, it's InfoVis plus virtual and or augmented reality. So the VR approach is that you kind of walk among the data, which could be useful, for example, for exploration of structure of large data sets. And I mean, if you remember that scene from I think it was Attack of the Clones, Star Wars Attack of the Clones, how they are searching for that planet Camino, how they have projected these planets into the library, and Obi-Wan is walking among those planets, and then okay, he's saying, oh, it actually should be here. So this is how I imagine the true immersive visualization and analytics in the coming years. And AR is basically that you may have a potential to make large display visualizations more accessible, or you can augment reality to kind of visualize directly in the space, which we're going to see in a second.
Yeah, by the way, like about 3-4 more minutes, but just so you know.
Yeah, I think we can actually take a break here, so that I can start talking about immersive visualization after the break, and that's gonna actually I only have like 35 slides today, so we're gonna take a 5-minute break and then wrap up the short lecture today and then discuss the exam. So are there any questions at this moment?
At this moment, there are no questions.
Very good. So let's take a 5-minute break, and I'll see you at 27. Yes. Okay, we might want to resume. Were there any questions in the meantime?
No questions so far.
Okay, very good. So
I have a question in the chat.
Yeah.
From
So
Zoom, sorry. Maybe I missed it, but could the slides be uploaded to the Discord?
I mean, why not? I mean, they're on Canvas, but
okay.
Yeah.
Then I'll just get them there for now. That's fine.
So okay. Let's continue. So we have talked about the immersive visualization and analytics, InfoVis plus VR AR, and let's talk about some approaches that are interesting approaches that appeared at IEEE Vis 2020. So the first one was called VRIA, web-based framework for creative immersive analytics experiences. It was actually quite a nice approach, which is so it allows you to combine VR technology with web applications, which could be interesting. So it's the technology stack is A-Frame plus React plus D3 plus Web VR, and it's a flexible open software. So you can use this framework for your own VR visualizations if interested, if you want to experiment with this. Then we had UvA's personal augmented reality for information visualization on large interactive displays. So here you can see that we have like a large display with various plots, where each of those participants is wearing glasses, and you can do things like you can bend the space a bit to kind of be surrounded. They have had experiments that this appears to help cognition. You can kind of fold things up, fold them down, and also what is nice is that you can if you project visualizations to a big display, and you have multiple analysts working together, then each of them can interact with the plots in their specific way. And then you can of course like reconfigure, use all these analytic interactions, and then they can possibly share their rearranged visualizations with the colleague if that's interesting for the collaborativeness. So this is pretty much what I have just said. This is the augmented reality example, and it's implemented in Unity. Finally, we had Fiesta, which is shared surfaces and spaces, collaborative data visualization in a co-located immersive environment. Here we see, so what happens here is that this is an example of so-called free roaming visualization, is that you have, so this is not really yet walking among the data, so the OB1 searching for Camino, but it's that because normally what happens in these immersive visualizations is that you can take those visualizations, you can put them on VR surfaces that are kind of predestined to accept your visualization. You kind of snap them to surfaces around you. So here they have opted to just let the analysts or the users walk around. So here you see that all of these walls are surfaces or acceptable surfaces for the visualizations. And they have also allowed them to arrange the visualizations in space. So this is something that you see here. So you just kind of create a stand with the visualization in the middle of the room. And what was interesting is that people tended to put 2D visualizations on the walls and 3D visualizations in the space around it. So that was a cool thing they have done, and that people were a bit shy to walk into other people's visualizations. So the collaborativeness was a bit limited, not by design, but by the let's say polite behavior of the users, because I mean it's experimental technology, so you don't want to break a colleague's visualizations by walking through it or something, because people don't really know how VR works that much yet. So, but this is a step towards truly collaborative VR, and I think it's an impressive paper. Again, this is what I have just said. This is there for this to be a bit of a study material. Yeah, so those were again 3 examples of the immersive visualization approaches. I think there were like 4 or 5 in total. So it's still in the early years. It's still an emerging field, but definitely has potential. And especially when the price of VR goes down, I think that we will see massive interest in this. Note that for this, classic information visualization and VA visual analytics design rules still need to be taken into account. So the VR and AR can help with the sense of overwhelming, and it can overwhelm itself, by the way, but it does not solve the problem alone. So like we discussed, for example, if we have the problem of clutter, then we cannot really solve it by saying, okay, so we're just going to project the data all over this huge room and people can walk around it, so they will not be overwhelmed. So problem solved, right? So instead of our correct clutter reduction techniques, we're just gonna show the data on a sufficiently large space. That's not a solution, right? So you still need to take into account these various design rules that we have learned previously. And also there are some artifacts of VR that can be overwhelming on their own. So there is a challenge, but well, in science that's a positive thing that there's challenge. So that means that you can write a paper on it. And I definitely consider immersive visualization and analytics to be a field with potential. The last hot topic that I'd like to discuss, and we have kind of touched on this with the last approach of the previous topic, is collaborative visualization. So we have multiple users working on the same task. And here, what is really key and what has gained traction in the last years is what's called analytic provenance, which has a bit of a convoluted definition, but I think that the simplest way to put it is that we understand the user's understanding insight. So basically, we track how the users arrive at their insight. what were the steps and interactions. So if you conclude that, yes, there is cancer in this population, then how do you know? Like what made you think that, right? So we might want some evidence. We might want some, okay, so what were the images, medical images that you have explored? What were the data sets that you have reference, compared together, you have joined maybe, and how did you come up with that? So what are the building blocks, the nuggets of information supporting the insight? And basically, so the point of all this is that visualizing provenance can help other users tackle the same or similar task. So well, that's A, and B also where I think it could be used, but that's a bit beyond the scope of this course, is that to create better interactive machine learning models. But it's definitely a topic that has emerged in the last years. We have, so one of the examples that I'd like to show is called crowd trace, visualizing provenance in distributed sense making. So sense making, you might recognize this loop. And I mean, if you don't recognize it, I strongly suggest you learn to recognize it. I mean, the exam is coming up in a week, right? So this is what we discussed in the visual analytics lecture. How do we get from external data sources to our final hypothesis or presentations or the deliverable, what we want to as an outcome of our visualization process? And here it's demonstrated on this kind of mystery solving task that they have given their users. So distributed sense making means in this case that multiple users work to solve the same investigative task. But the problem is how do we actually find provenance errors, right? So this is a mystery. So this is a synthetic data set. So that they have invited some crowd workers to solve a mystery. The mystery is about answering where is the target location of a fictional terrorist attack. It came with 15 documents and the following clues. You can assume the clues are all correct. A C4 plastic explosive bomb will be detonated at 9 a.m. on 30th of April 2003 by a group of terrorists: Matthew Hamilton, Henry Kim, Hugh Ash, Sam Baines. And you have all those various documents, and you need to find where the terrorist attack is going to take place. So that's the task. And the problem is, how do we find provenance errors, right? Because of course, this is a synthetic data set, but in visual analytics, the right answers and correct conclusions are not specified beforehand. So, because I mean, why would we analyze such a data set in the first place? So if we already know the correct conclusions of the data set, then we would not need visual analytics, right? So, and the test benchmark data sets can only take us so far. So how do you actually know that somebody has made an error in their train of thought? And the proposed solution in this paper is use crowd auditing. So what you do is you visualize provenance. So you visualize the steps the user has taken to their insight, and this adds clarity to the analyst's mental process. And then you basically audit this process using crowdsourcing. So I mean, of course, there is no guarantee that a past audit means correct conclusions. I mean, especially if you're doing it on somewhere like Amazon Mechanical Turk with unqualified crowd, but still the error will be reduced by a lot. So if nobody sees it, then the error rate will be probably higher. So I mean, you can view this like as a bit of an analogy to those adversarial examples with explainable AI. So it's not a guarantee if you run the adversarial examples successfully, but it's definitely better than not running them. So that's so I see a bit of a similar logic here in this crowd trace. So I think it's a nice approach. Then we have what's called VisConnect. You might actually from this screenshot you might recognize the D3 code. It's VisConnect distributed event synchronization for collaborative visualization. It's in my opinion a very nice piece of technology. So what it does, it allows you to it's basically the D3 library, and it unlocks true web-based collaborative visualizations. So say that you would have an interactive visualization and you would have 3-4 people going there. So say that it would be a graph visualization where you would be able to rearrange the nodes. It will be a node link diagram. You'll be able to rearrange the nodes and links. So if you would do it in naive D3, that people would log in, that everybody would have, or not naive, native rather, not naive, then people would log in to their session, but then they will of course drag around their nodes and interact with the visualization, and they would not arrive at the same visualization, right? But if you use these VC calls, so it's like you see here, we have VC random and we have VC drag. So random is there just to see the demo example, but VC drag means that that if you drag it, then basically everything. Oh, sorry. Sorry, I lost my train of thought there. Yeah, so if you use VisConnect, then this drag, so user A would drag, say, this violet node or purple node here, then then users B and C will see it the very same way. And the way they do this is they use very lightweight calls. So you just do this VC random, VC drag, but this looks like a pretty vanilla D3 code. So you don't have to really go through a lot of hoops to facilitate this collaborativeness. I think it's a remarkable software contribution. I think it should be available online. So if you want to try that out. I am not exactly sure how it works internally. So if you're interested in, okay, how do they make this happen? How do they connect these visualizations? I am not sure 100%, but I have seen the demo and it looked very nicely. And I mean, they have even done a stress test. So I was fortunate enough to be at that very session where they have demonstrated, and they said, okay, if you don't believe me, just click on this link, and all of you will connect to the same visualization and kind of drag it around. So it's kind of cool that all the participants of the Vis session were dragging in the same visualization. It indeed worked. It didn't crash. So it takes guts to create this really live demo for a large audience, and I mean they have succeeded. So I think it's a very nice contribution. Also, then we have Track, which is a library for provenance tracking in a web-based visualizations. What this does basically is that it to your visualizations, it will add these trees. So what you have done, then it will unlock undo and redo, which is great, because neither D3 nor React, I believe, do this very easily. That you can do undo redo. So this is a nice framework where you can kind of go back in your train of thought. So definitely useful thing. And it's also web-based, so you can add this to your web applications. Actually, it's a JavaScript library which is available via Node.js package manager, and it adds provenance capabilities to web-based visualizations, as we discussed. Yes. And this is the last content slide of the course, and it's called Why Visualize. There's been a remarkable paper, which is a visualization of reasons for visualization. So it's a meta paper kind of. It's called Why Visualize: Untangling a Large Network of Arguments. Yeah, so you can look at this paper if you need extra motivation for this course. I think this is suitable content for the last content slide, and I would like to thank you for attending the course. It's been a pleasure, and I wish you good luck with the exam, which we're going to discuss in a minute. So thank you. If there are any questions, we're gonna talk about the questions from this lecture, and then we're gonna jump into the free exam discussion. Thanks. Are there any questions?
For the moment, I can't see any in the chat, so no.
Okay, so in that case, Christina, thank you very much for helping me with chairing the sessions. Much appreciated. And if you want to, you can depart now. You can stay with us if you want. And now we're going to move towards pretty much like a chat session that we might want to discuss the exam a bit. So thank you.
Yeah, thanks, and of course already good luck everybody.